Okay, we're coming down to the home stretch. Today, I wanted to talk about functions again. I think students are understanding most other concepts that we've covered, like arrays, while loops, if statements. I think students have those all down really well. I think functions are still the one concept that maybe we just need to see a few more times before we go into final exams. So first two parts, we'll be talking about functions. Then we're going to see how functions are used in the Strategic Sevens project. And then we'll talk about end of semester logistics, final exam, what the remaining lectures are going to look like. All right. Any questions on anything before we get started? Okay. Cool. So creating functions. First off, if we're to define a function, what are some of the key components of a function?
Well, you gotta have data type.
Okay. For which? Or like what does the data type represent? Like why are we saying the data type? Yeah, so we need to say essentially a function is like it can take an input, and if it takes an input we need to specify what kind of input it takes. Then it completes some specific task, and then there's also a return value. Like it can return an output. Yeah. In terms of why functions are useful, it can make the code clear. So the way you name the function, it can be very clear what task that's completing. And that whoever calls your function doesn't need to know how it actually works. They just have to know how to call it. So like, does anyone here actually know how the like pow function is written or how it works? If we do like pow of 5 to the 98, that's raising 5 to the 98th power. Maybe that's just doing 5 times 5 times 5 times 5 98 times, like with a while loop. We don't know, but it doesn't matter for us. As long as we know how to call the function, that's what's important. So it can make the code clear. It's what we call an abstraction. The common analogy, I didn't use it in this class, but what a lot of textbooks use is like driving a car. There's a lot of functions in a car. Like you could do the function turn left, and the input is turn the steering wheel left. But you don't have to know under the hood how the car is actually turning left, right? With cars, they give us a very simple abstraction. Like do these things and you can drive the car. You don't have to know how it works. You can reuse code. In the examples we've done in class so far, we haven't really gotten a chance to reuse code with our functions. But once you go to industry and you do big projects, then it's the ability to reuse code. I guess some functions. So when we do like the length of a string, like we do dot length, that's a function where we keep reusing the code. So someone's written that one time, and then every time we call dot length, we can run that code again. Easier to test big projects. So once we make a small function, we can test it, and once we know it works, then we can use it anywhere else in the code. And if something else breaks, we know it's something unrelated to the function. Putting it into kind of the final homework assignment I released on Monday. I made the due date 2 weeks from now instead of 1 week so that you all can prioritize final projects for this week. But essentially, it's taking the Wordle project, but having you create functions for each of the parts that you had written in the project style. And you'll notice that the total code, once you use functions, like this would be what goes in your main code. And it's really just like 1, 2, 3, 4, 5, like 6 to 10 lines of code based on how you define and initialize the variables. But anyone who looks at this code should have a very clear idea of what's going on. So it's like we check if the game's over. If it's not, then we get a 5-letter guess. We increase num guesses by 1. We color the guess. We keep doing that until the game is over, and then we print the end game message. Questions here? Do people see though how with functions it makes the code much clearer to understand what's going on, as opposed to like right now if you look back at your Wordle project, it might take you a little bit of time to figure out what's going on again because we had all the nested loops and we had a lot of stuff going on. But if you looked at this, you would within a minute be able to tell what's going on. Yep.
You can name it.
What was it?
It's like more clear, like you can name it.
Yes. Exactly. Like ideally in your Wordle code, you would have put like comments for each of the sections, and that would have almost served like the same purpose. But function names are still a little bit clear what's going on. Yeah. All right. Okay, so then what the function diagram looks like, our inputs we call parameters in computer science. The output we call the return value, because that's what we're returning back to whoever calls the function. One thing here, like when we say get 5-letter guess, if we just call this function by itself, it will run and it will give us back a value. It returns like a 5-letter guess. Why do we set like guess equal to that? Like what happens if we just had it like this?
You gotta make a variable for when you call it, right?
Yeah, essentially like this function is doing all this work and it's giving us back a value. But if we don't store that value anywhere, like it's essentially lost, right? We did all that work, and if we don't store it, then we can't use it later on in the code. So that's why typically if a function returns something, we'll set it equal to a variable. Like we'll do an assignment statement. That way we save that return value. Does that make sense? Okay. Okay. So now the actual parts of the function definition. What's the thing that comes first? Data type of what?
Function.
Okay, and specifically, yeah, of the output, like what the return type is going to be. Right, so we first have to say what this function is going to return. What comes second?
The
Name of the function. So if anyone wants to call this function, they would say add, and then what's in the parentheses?
parameters.
Cool. I think people have gotten pretty good at defining the function actually, because you put all the data types. You're essentially creating the contract. You're saying how the car works under the hood. I think when we get to the second section on calling functions, people still put all these data types when they call the function. Why do we only put it when we define the function? The different data types, like the doubles here. Yeah, okay. Kind of a belly word question. Yeah. Essentially, because we're creating it for the first time, we have to say what the data types are.
Yeah.
But if it's ever called again in the future, like we don't have to again say what the data types are. Right? Okay. Cool. So I'll have you all, and I want you to do this one by yourself actually, and I want to come around and see where people stand on this. So you're going to define a function. I'm giving you the word of the function. The name of the function is letter and word, but you need to think about how to add the other part that goes. And you don't have to write the whole function. I just want like the top line, just defining it.
So you just want the top line?
Yep. Yep. Even if you're not fully sure, write something down just so I can see where people stand. Think about what the return type is going to be. Think about what parameters you need to make the decision on true or false. If you have an answer, raise your hand. Parameters look good. What is the return type going to be? So we're one more point out there. Like what other data would you need to make this decision? Okay, we'll bring it together and just check the I guess, what is this function at the start here?
No, I'm just writing down that.
Oh, okay. No, you're good. Sure. Nice to see you. I think for both of you, for the target letter, it could be a different data type. Okay, let's bring it together. I think people are on the right track. Okay, so generally, how I would approach this kind of problem, first is to think about what the return type is going to be. And so generally in these problem descriptions, I kind of tell you what's going to be returned. Ideally in the future, you would also be able to read the problem and kind of see. So if we're trying to see if the letter is in the word or not, like just in English, if you were to think about this, like would you, if I asked you if like the letter B is in the word boy, are you going to tell me like the answer is 5? Like, are you going to give me a number? No, you're not giving a number. Are you going to give me back like another letter? If I ask is B in boy, are you going to say, oh, the answer is B? No. So we know it's not like a char. We know it's not a string. It's essentially I'm asking a yes or no question. If a function is asking a yes or no question, what is the return type going to be? Bool. Cool. So in this case, I said it pretty explicitly, returns true or returns false. In the future, I might not be as explicit. And it would kind of be up to you to see if the answer is yes or no, then the return type is going to be a bool. Okay? So bool is letter in word. Parameters. A lot of people got one of the parameters, which was string word. So yes, like we're given a word. We need that as a data parameter so that we know whether to return true or false. Some people forgot the second parameter. What else? What other information do we need to make this decision? Yeah. Like if I just told you, is the letter, but I didn't tell you a letter, and I asked, is a given letter in the word boy? Like you wouldn't be able to give me an answer. You would have to know what the letter is as well, right? And so what data type can we use for the letter? Char, because it's just a single letter, and then string word, okay? Questions here are on the thought process of how we got here. Okay. One other quick thing I want to go over we used this example before, the isVotingAge function. This one also returned a bool, and it took the age as a parameter. We had this like if age is greater than or equal to 18, return true, else return false. With functions, so if we were like couting these statements, then yes, it would have to be set up like this. But with functions, you can set it up like this. So just to show the difference, before we had the else return false. Now we're just saying return false at the end of the function. Why does this work? Yeah.
Because if it's true, it's just gonna get off the function. It's not gonna be one.
Yes. So with functions, only one thing can be returned. So if age is greater than or equal to 18, we return true, and the function immediately ends. Which means that if we ever got to the end of the function, what do we know?
To that point, it's false.
Yeah, and specifically that age is less than 18. In this code, if we ever get to the end of the function, we know age is less than 18, so we can return false. Is that clear? Any questions there? Okay. Especially for your Strategic 7's final project, this is going to come in really key. Some people, especially in the, in the isGameOver function on the lab, a lot of people said, if the scores are greater than 200, return true, but then they didn't return anything at the end of the function, and then they were getting an error that said, like, reached end of non-void function without returning anything. Does anyone know why that error is coming? Could I?
Because they never put a return false.
Yeah, essentially, like, in very limited cases, the function was returning true, and most of the time it wasn't returning anything. And so the C++ compiler got confused because it said you're going to return true or false, but the majority of the time you don't return anything. So by default, after that if statement, you had to put return false. That way at least something is being returned in every case. Is that clear? Okay. Any questions before we move on to calling functions? Again, I think people are pretty good at creating functions. I think calling functions is where there's a little bit more difficulty, partially because we don't have as much practice with it. Okay, so in this example, I created a function called calculate circle area. What's the return type for this function? It's a double. We put it here. What are the parameters? How many do we have? Just one parameter. It accepts a radius. It takes the area, calculates the area. So notice this function is calling another function. You can have functions call other functions. Like it'll just be a chain. Okay? So in this function, we call this one pow. And this is saying take radius and put it to the second pow. Again, we don't know how the pow function actually works. We just know how to call it and how to use it. Okay? And then it returns the area in the end. So in our main, if we wanted to call this function, I'll give people 30 seconds to think about it. Think about what should go on the right side of this equals so that we can get the area. Okay, so what's the first thing we have to do if we're calling a function? Yeah, so we have to copy the exact name of the function. So the name of the function is calculate circle area. And then what can we put in the parentheses? Yeah, so if we're doing it in terms of variables, we can do r. Do we have to say double r? No, so we can just say r. Why does this work? Because the r here doesn't seem to match up with double radius.
They don't have to be the same variable.
Yeah, so the only thing that has to be the same is the function name. The variables here don't matter. The computer sees this r, and it just immediately converts it to the value 3. So we're really saying calculate circle area of 3, and so this radius, which is the first parameter, is being set to the first value here. So what's the value of radius going to be? 3. All right. So then this is going to run. It's going to be like pow, so 3 squared is 9 times 3.14. We're going to get like 28 point something. So what's going to be printed at the end here?
Area is whatever.
Yeah, like 28 point something. Okay? If we didn't store this calculate circle area in a result, we wouldn't have been able to see out it on line 14. That's clear? Okay. Okay. One thing I want to talk about is variable scope here. So let me pull that up. Okay, so let's say we had like another variable here, area equals, let's just give it some random value, like 10. And then let's also do, okay. Okay, before we run it through it, we said the result is going to be like 28 something. And it was returning from here. So, okay, we'll step through it. So we run through the code. R is 3, area is 10. Result is going to be equal to whatever is returned from calculate circle area. The right side runs first. So what line is going to run next? Yep, we're going to jump up to calculate circle area. What's the value of radius going to be? 3. What's this value of area going to be right now? Is it going to be equal to 10? No. So when we create a new function, new variables are being created. This is super key. This area variable here on line 13 is a different area variable than the one on line 6. That's why we had to put double area. We had to define it in 2 different places. Okay? When we create a new function, new variables are created. It doesn't matter what was used in main. That's why we have parameters to pass values from the main to the function if we do actually want to share values. Okay? So at this point, area is still going to stay a question mark, and we're going to calculate this new area on line 7. Okay? So then we calculate area, it ends up being like 28.26. And so when we return the area on line 8, can anyone guess? So what's going to get printed out on line 15?
Line 15.
Mm-hmm.
Area is
Area is 28.26, because this 28.26, we're returning it here. It's going to get stored in result, and so we're going to say the area is 28.26. What's going to get printed on line 16?
The area variable is 10.
The area variable is 10, because this area in here never gets changed. It doesn't matter that it has a similar name as this one. They're in 2 different memory locations right now. Okay, so if we're to keep stepping through it, we're going to return area, which is 28.26. So we come back to line 14. Result stores that 28.26. And then note, once we exited this function, this like radius and area variable just completely disappeared, because that function is over. So then when we print out here, the area is 28.26, that's what you all said. And then the area variable, now hopefully it's more clear. I think everyone, or people who shared said it correctly, but what's going to be printed now? The area variable is 10, because that's the only thing we have left. Questions here?
So, why would you even want to make like a variable the same name?
So the big part with functions is it shouldn't matter how the function is implemented. So if you could imagine in the like POW example, when we had it here, what if the POW function, what if it was created like this, where it was like double POW, it takes in like a radius and an exponent, and like we'll call it R in here, and let's say in here it like created some variable radius. Then it would like mess up the radius that we're using in our code. So it shouldn't matter what they actually do inside of their function. We don't want it to mess up our code. So that's why like the names don't really matter, like they're 2 completely separate memory locations. In terms of why, if we are creating the function and we're calling it, why would we use the same name? Sometimes it's just the best name to use. Like area is like a good name to use here. And then it might also be a good thing to use in here. So, all right. There will be a question like this on the final exam in the written part, where it will be like, essentially like exactly like this. Like they'll call some function, I'll have some variables, I'll ask you what the values are at the end. Okay? And I think really the big takeaway from here is if you want to pass data here, you have to do it through the parameter. Everything else is separate. Cool. Everyone good? Okay. I guess before we'll take a small detour, we'll come back to this section. We'll talk about end of semester logistics now while we're on it. Okay. Remaining assignments. I released the final homework assignment on Monday. I set the deadline to 2 weeks from now. I think generally for the remaining assignments, get them in before December 4th. The best way to study for the final exam is to complete all the assignments. The exam will look very similar to the midterm. We'll talk about it in a couple of slides. Top priority for this week, though, has to be final project. I can't give any extensions on final project. It has to be submitted Tuesday, November 22nd. If you don't submit it by then, the highest grade you can get in the class is an 85%, right? You can essentially take whatever grade you have right now and subtract 15% if you don't meet this deadline. So, strict deadline. I don't think the project will take a ton of time, but it just has to be a strict deadline, right? Because semester's ending. So you have to do that, and then after Thanksgiving break, there will be a 1 week period where you can book the 20-minute appointment with the Googler to officially get the project graded. Yep. Questions here? Okay. Remaining lectures. On Friday, we're going to go over the last new topic. We're going to talk a little bit about vectors. Monday, I know some people are going to start traveling for Thanksgiving break, so I'll make the Monday lecture optional. It'll essentially be the project working session. So, if you still have work to do on the project, come in and I can help give feedback. Or even if you're done with the project, you can still come in and I can make sure everything looks good, so you'll get full score on the grading part. The Monday after Thanksgiving break, we'll do a final exam review, and then the Wednesday, we'll do the practice final exam in here. We'll do the written part as practice, and then I'll leave the coding parts as an optional homework assignment. Okay? Any questions here? Cool. We're kind of coming down to the home stretch. Just 4 more lectures. Final exam times. This time, no flexibility. You have to come into your slot. So you all are the 11 a.m. Monday, Wednesday, Friday. So 1 o'clock to 3 o'clock, Tuesday, December 6th. Okay? Any questions here? Again, 1 o'clock to 3 o'clock, Tuesday, December 6th. I'm going to try to make the exam about an hour and a half, but you would have 2 hours total to work on it. Make sure you come on time so you get the full time to work on it. All right. And then exam topics. So like the midterm, you may create a 3x5 note card. I'll go into my office and grab it, and you can take a note card on your way out if you want to start making that. Again, I think the best way to study is look through the slides. The stuff that you know, you don't have to put on your note card. The stuff that you think is harder to remember, maybe like function headers or calling functions, stuff like that, put on your note card. And then you can bring in the note card, use it on the exam. I feel like people can pretty much guess what's going to be on the exam. So let's do it together as a class. What do you think is going to be on it? Functions, 100%. Pretty much how I've structured these last few homework assignments. Let me take an example. I think the Wheel of Fortune one and the Wordle project ones are both good examples. So homework 11 and then homework 8. Homework 8, I essentially had you create these different functions, right? Some of the functions had stuff to do with strings. Some of them will have stuff to do with arrays. And then at the end, I have you call all of those functions in a big, put all the code together, right? So functions, define, and call them. So I'd say check homework 8, homework 11. Those would probably be the best examples of what the coding part of the exam is going to look like. All right, what else? Arrays, loops.
I'm going to learn more about structs.
Structs, I won't have you define or create structs. I might have you just do the dot notation. It would probably be on the written part. Just what is the output going to be? And I'd have the struct dot, whatever.
We're going to know that log thing.
Runtime, yes. So runtime analysis.
Algorithms.
Yep.
Did you do syntax or something?
Sorry, one second. One thing on the big O notation, it would probably just be O of 1, O of n, O of n squared, and O of log n. I know there's a lot more big O notations, but those would be the 4 that I would focus on. Okay. Cool. What? Someone else said something else?
I said, would you do anything for syntax? Making sure you know how we do by defining functions and stuff?
Syntax, like kind of like the debug my code kind of thing. Yeah, it'd probably be a debug my code. Yeah. Anything else? Oh, if statements, right? You need if, else if, else. Cool. And a lot of these will be combined, right? Like I'll have you write a function that uses an array. And most likely if you're using an array, you have to use a for loop. So we have each of the individual parts. Most of these later homework assignments and labs have been combining them together into bigger, I guess, combinations. Those are your best study tools for the final exam. All right. I think this is a pretty good list. If I think of anything else, I'll let you know. But I think that's, yeah, final exam topics. Cool. Any questions? Final exam? Again, just like the midterm, like midterm grades were high. And there's a very strong correlation between people who are doing the assignments on time, felt like they understood the assignments, and how you did on the midterm. I don't think I threw in any trick questions. I won't be throwing in any trick questions here. If you know how to code and you know the stuff we've done in class so far, you'll be fine for the final exam. Yep. But if I will caveat that though with, if you don't know what's going on, it's going to be hard to BS your way through it, right? Like if you don't know how to set up a function, you just like won't be able to do the coding problems. Like I'll try to give partial credit where I can, but your code won't run if you can't set up a function. Right? Okay, cool. Everyone good there? Okay, final part, functions in strategic sevens. So we have this get game state function. In the function, it creates a struct, but again, we don't have to know exactly how the function works. All we know is it's going to return this data type, game state. So again, we create this game state struct, so we essentially created a new data type, that's what's returned, and it asks for 3 pieces of information. So if we were to call this function, how could we do it? Mm-hmm. Yep, so the name of the function, get game state, I think in lab people were putting like this name here, but really the name of the function is the second thing in the header. So you'd say get game state. A lot of people were putting int current player index. Yeah.
What does like the first game state stand for? Like,
This was the return type. So
Because we made a struct for it.
we made a struct called game state. Normally this is like a double or a string or something, but we created a new data type called game state. Yep. Okay. So get game state, current player index, turn score. In this particular case, in the function, we have to see what data we have available to us. And in this context, we had something called role. And so current role is going to be set equal to role. Yep.
So this is in the main function, right?
Yep. This bottom one is in the main function. This one is above the main function. Yeah.
So what data type would be for that game?
This one is the same one in here. Like, you're right. It was defined a little bit higher in the function, but this was game state equals get game state. Yeah. Whatever this data type is, it has to match the return type. Right? Yeah. Yep. So that's what our next example is going to be. But everyone good with this one? Okay. So yeah, now the void function. So above the main, we created this function called void print round update. What does void mean? There's no return value, which means we can't, like in this example, because this part returned something, that's why we could set whatever was returned equal to the game state. But if there's no return value, we can't assign it to anything. So in this example, we just call like print round update so that the function runs. But because it doesn't return anything, like we don't have to assign it to a value. We just call it exactly as is. Are there questions here? When calling it, I think a common mistake I saw was people were putting void here, like void print round update. Again, we only have to put what the return type is when we define the function up above. When we call it, we just give the name of the function. Everyone good with this example? Okay. Okay, the get move function. So again, we create a new data type called move. That's what the return type is. we call get move, and it takes in 2 parameters. So what can we put here? Mhm. Mhm. Yep. So essentially, like this game state, that's what we were getting from here. Like we said, get like game state is equal to this, and then on the next line, we use that game state variable in here to help get the move. So after every roll, we get the updated game state, and then we use that game state and whichever player's turn it is to get what the next move is. Okay? Let's dive a little bit deeper into the get move function, because that's what's calling all the work that you all are going to be doing. Line 68, final project. Okay. So again, make sure you watch the 5-minute video to see how to get started. There's only 2 files you're going to be changing in here. You're going to be changing the main a little bit, just so you can see like what kind of output you want. You can either play like a 1 versus 1 game, or you can just play against all the bots to get all the winning percentages. Sorry, I made some changes. So you're going to be changing the main function, and then you're going to be creating a player file. You're not going to be changing anything else. In the player file, you're going to be writing these 3 functions. Should end turn, should double turn score, should erase roll. Okay? And then we've set up our code behind the scenes to help call all of these functions and figure out what to do. So I'm just going to show behind the hood what's happening. You don't have to change the following parts, but I think it's kind of cool to see how this all fits together. So in the game, line 68, we have this get move function. So essentially, we're going to be calling your player functions to see what move to do next. And the first thing we're going to do is we're going to check if the user has their erase roll power available, then we're going to ask you. So this is kind of a weird syntax with classes. You don't have to worry about this too much, but we're going to get your player and we're going to ask your player, should we erase the roll? And we give you the current game state. So this is calling your function right here. Do people see that? Like should erase roll, that's what you're defining right here. You're going to give me back a bool, and I give you these parameters, and you're going to use that information to return true or false. So when it's called in the game, it's essentially you're going to give me true or false. So if this whole thing is true, then we say the move is return erase roll. Okay? So you don't have to, in this function, you don't have to check if you still have the erase roll power. Like we check that first before we call your function. Questions here? Do people see the link between how like get move is going to call your players should erase roll function?
Can you explain to me what the arrow means?
The arrow is, so player is a class, and normally the way we call class functions is like player dot should erase roll. In this case, it's a reference to the player class, which you're going to learn about in programming too, like references and pointers. So with references and pointers, you have to use the arrow instead of the dot. But you'll literally spend like 2 or 3 weeks on that in programming too. I think the big takeaway though is in your player class, we call should erase roll, and we give you the game state. That's more what I want you to take away here. Okay. So if you don't erase the roll, then the game checks, all right, you didn't erase the roll, let's see what the roll is. If the roll is a 7, then we automatically end the turn for you. Like we don't ask you, do you want to end your turn? If the 7 is there, we automatically end it. Why do we not ask you if we should end the turn? Yeah.
Because then you could just say no.
Yeah. You could essentially break the game, right? You could lie and say like, oh, it was a 7, but don't worry about it. Like, let's keep rolling. So that's why, like in this case, we have to explicitly do it for you. That way your player class doesn't hack the game. Okay? So after that, what do we know at line 81 onwards? About the current roll sum?
It goes back to 0.
Not back to 0. It's essentially we know the current roll is not a 7. Because if it was a 7, we would have returned here and the function would have ended. So at this point, we know the roll is anything but a 7. which means that we can keep going as normal. Like then we can ask you, do you want to continue your turn or not? So we ask you here, we ask your player, should we end the turn? We know the roll is not a 7, we give you all this information, we ask you, should we end the turn? If you tell us, yes, true, end the turn, then we come in here, we check if you have your double power, and then we ask you, should we double your turn score? And if you say yes, then we say return the double turn score, otherwise you just ended your turn as normal. Okay? And then at the very end, so after line 92, we know that you didn't erase the roll. We know that the roll was not a 7. We know that you did not end the turn. So what can we do at the end? We always have to return something in a function.
We just keep going.
Yeah, essentially if you didn't take any of the other actions, then the default move is to just keep rolling, continue your turn. So we didn't have to say we didn't have to put an if statement here. Essentially because everything else above it was false and we made it to the very end, then we know, okay, we can just keep rolling. And then this will loop again. So then we'll roll the dice again and we'll do it all one more time. Okay? Questions here? This is another huge advantage of functions. Like if we didn't have functions, we could not have written this code. Because essentially you all would have had to have created your own like game.cpp files and it just wouldn't have worked. Like you each would have had to have put your code in here, but then we couldn't have like run everyone's stuff against each other. So the only way this works is everyone creates their own player files, fills in these functions, and then we can have everyone's players compete against each other. Yeah.
Mine doesn't have a game file.
Yours does not have a game file? I probably hit it because you don't have to change it. But if you click on like the black box, you should then be able to see it. But I think by default, I only showed the main file and this ASH1 player in the game state. Because those are kind of the 3 files you can use as reference. Okay, other questions? Does this make sense or did it just make things more confusing? Makes sense? Okay. Again, even if it doesn't make sense, that's the cool thing about functions. You don't really have to know how this works. The only thing you really have to know is you have to come and change these 3 functions in your own player file. Like don't change it in ASH1 player. Like make your own player file and then change these functions. Yeah.
So we have to copy all of that and then
Yeah, so the 5-minute video gives the instructions, but essentially you would copy this, create a new file that would be like John Oligo 1-player, and then the 2 things you would have to change is like, this would be like John 1, and then your own code for these 3 functions.
we will delete that one or do we want
You can leave this file just as a reference. That way also as you create multiple player files, you can always use this to like copy and paste to make your new one. Yeah. Cool. Okay. And then we have a couple minutes left. One final thing. Remember to document your different player strategies. So people have already started making strategies. They're doing well. Make different files because we need to go into your code at the end and see like that you've made at least a few different player files so we can see that you've been iterating and you didn't just do one and then stop. I gave like the example documentation. You can either do file, make a copy of this, or you can just like copy it into whatever doc format that you prefer. Essentially, you're going to say the high-level description of the strategy. You're going to say what your win percentages are against each of the bots. And then you're going to say like the observations and analyses. So in this example, I was like, let me zoom in a little bit. I was like, I noticed when I ran the game, hardball was at 198. I was at 59 points, but I ended my turn after 2 rolls. What should I have done instead? I probably should have kept rolling. So I'd be like, all right, now when I make ASH1 player 2, I'm going to, keep most of my same strategy, but I'm going to try to, in this particular case, try to keep rolling. And then I'll, copy and paste this, make another description about what I tried, see what worked, what didn't, and then make my ASH1 player 3, and then 4, right? Any questions here on the documentation process? Yep.
How many classes are we going to submit?
I'm not going to give an exact number. It should ideally be like at least like 3 distinct strategies, I would say. Right? If you like, if you made 10 strategies, but you were only changing like one number between each of the 10, that's not really like that distinct a change. So I guess if I were to give a number, like at least 3 distinct somewhat strategies.
You can make those be different players.
Yeah, so it'd be like Omar 1 player, then Omar 2 player, Omar 3 player.
And you got like different pages for that.
So you would create it. So in here, you would do like in the players file, you'd create a new file,
Okay.
and then you do like Omar 3 dash player, something like that.
Yeah, just copy the stuff on the player file to that one.
Yep. And again, this 5-minute video kind of shows all the steps exactly. Yep. Sweet. Okay. That's all I have, everyone. We're in the final stretch. Let's finish strong. This week, final project. That's the big one. Lab today at 5 p.m. We're going to be doing more work with the project, so try to come in. Also, if you can, try to bring headphones into lab today, as there's some video stuff to watch. If you came in late for attendance, please come up.